9.1, Intro to Probability. So, when we talk about probability, it is always we can think of it as the frequency of an event over time. Now, I say it that way because, for example, if I'm flipping a coin, the probability of getting heads or tails is supposed to be 50%, right? But a lot of times, let's say I only flip it 3 times. I'm going to get 2 of one and 1 of the other. My probability is 66%. But if I go ahead and flip it 2 more times, it gets closer to that 50% probability. So the more times you do it, the closer it's going to get to that actual event of what you expect to happen, right? So chances are if we flip the coin 1,000 times, it would be really close to our 50% probability. So that's why I say it that way. It's the frequency of an event over time. So how many times you expect it to happen. It's expectations. So a lot of times what we're going to say is we are also going to do number of times it occurs divided by the total. All right, so I want to talk about rolling 2 die first, okay? When we roll 2 die, there are 36 different possibilities that can happen, all right? And you don't have to write these down. They are in your book on page 679, but I want to show you when we're talking about them what we have. So one roll could be a 1-1. You get 1-2, 1-3, 1-4, 1-5, and 1-6. We can also get a roll of 2-1, so the different die repeats, right? 2-2, 2-3, 2-4, 2-5, and 2-6. 3-1, 3-2, 3-3, 3-4, 3-5, 3-6, 4-1, 4-2. Get these all written up here. 5-1, 5-2, 5-3, 5-4, 5-5, 5-6. And the last possibility is a roll is a 6-1, 6-2, 6-3, 6-4, 6-5, and 6-6. Okay. So now if I were to say to you, what is the probability that the sum is 11? So out of all those different possibilities, how many of them add up to 11? So in this case, there are only 2 of them that add to 11, rolling a 5 and a 6 or rolling a 6 and a 5. That's the only possibilities, right? So we have 2 out of 36, or 1 out of 18. Maybe we do the probability that the sum is less than 6. All right. So now we got to go through here and decide less than 6. And the way it's set up, you can see any of them in this diagonal all add up to 7, right? The diagonal right above it, these add up to 6. So I have the ones that add up to less than 6 are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10 of them out of 36, which reduces to 5 out of 18. So your first 8 problems today are honestly just looking at these 36 rolls and writing down their probability. Anybody have a question on that? Okay. So then probability, and I know this is going to sound like a silly question, but I just got to make sure. For the perfect probability, what should all of your numbers add up to? 100, right? They should add up to 100% or 1. So one of your questions today, which I don't think I have to go through, but one of your questions today wants to know, it gives you a table with their probabilities, and wants to know if, let's see, how do they word it in here? Wants to know if it's valid. Okay, well, if you add up your probabilities and it's bigger than 1, then it's not valid, is it? If you add them up and it's less than 1, it's not valid. But if you add them up and it equals 1, then it is. So I just wanted to point that out before we keep going. Okay? All right, moving on. Probabilities where we have several different things that can happen. Today I want to talk about probability where they use or and the probability of when they use and. So they're going to say this or that can happen. If they say or, that means that you are going to add the probabilities together. If they say and, the probability of this and that, then you are going to multiply. Oops. The probabilities. And now all of these probabilities are assuming that they're general probabilities. It's not like we're drawing something out or anything like that. You're given the probabilities. So let's do an example of what I'm kind of talking about here. Let's say, I don't know, I have a crayon box and the color, oops, put the color on the bottom, I guess. Is that what I want to do? No, let's put the color on the top. The color, let's say, in this crayon box, the probability of there being a blue in there, there's lots of different shades of blue. Let's say this is 0.3. Right? Red, let's say this is 0.1. Let's go yellow. We'll go 0.2. Green is 0.3. And let's say brown is 0.1. Okay, so here's the table we're going to refer to. So first of all, what if I want to know the probability of blue or green? So we're taking the blue, which is 0.3, and we're adding it to the green, which is 0.3. So we get a probability of 0.6. I'm going to okay, let's change it a little bit. What if I said the probability of me not using yellow? Add all the other ones up, or we can do 1 minus what the yellow is, right? So we can say 1 minus 0.2, which is 0.8, or we can say 0.3 plus 0.1 plus 0.3 plus 0.1, which also equals 0.8. Either way. What if I said, what's the probability of how about neither blue or red? Why do you think it's 0.4? Okay, but it's neither of them. Yes, very good. Very, very good. So, in this case, we could say 1 minus the probability of blue, which is 0.3, plus, since it's or, the probability of red, which is 0.1. So we have 1 minus 0.4 or 0.6. Okay, how about what is the probability that I'm going to use a blue and a red? Yep, so 0.3 times 0.1 equals 0.03. Yep, make sure you get the right decimal in there. Well, that I'm going to use, what's the probability I'm going to use blue and red out of a box? Right? Okay. Let's try this one. One more. Let's do the probability that I'm going to use. How about yellow and green? So yellow is 0.2, green is 0.3, so my probability is going to be 0.06. Hi. Time out 1 second. I'm just going to pause this real. There you go. So any questions so far on what it is when we're doing the probability? Okay. There is one thing that I need to clarify how it's written in the book and how it goes in here. So I'm going to kind of go down a little bit. So let's say the probability of, if they say first brown, then yellow. So now it's giving you a direct order. So you have to multiply it in that order. So in this case, our brown we said was what, 0.1? Yeah. And yellow is 0.2. So this is 0.1 times 0.2, which is 0.02. Okay, whereas there is one in your homework today that it says the probability of, how do they word that? 1 is yellow and 1 is green. All right, so this is written a little bit different than the probability of using yellow and green. Right? This says I'm going to use both. This says that I'm going to do possibly 1 and green, or I might do green and then yellow. It doesn't really say what order I'm going in. So for this one, it changes it a little bit. First, we're going to multiply this as the first option. So what this is really saying, I'm going to write it this way, is that first we're doing yellow and green, or we're doing green and yellow. You guys follow the difference between this one and this one up here? So if we do it this way, we're going to have 0.2 times 0.3, or means plus, and then we got to do 0.3 times 0.2. So 0.2 times 0.3 is 0.06. 0.3 times 0.2 is 0.06. Which means when we add those together, we get 0.12. This is the toughest question out of your whole homework today. All right, any questions? You guys are going to find this really easy. We're only doing 1 through 22. You're going to fly through it. Tomorrow we're going to start talking about cards and euchre and some different probabilities of having practice if it's raining and not raining, and a whole bunch of other stuff. So it'll be lots of fun. Okay? All right, let's get this done.